So welcome to the review of the new basic questions. We're now covering sections 3.6 to 3.10, and section 3 is probably the one that has had the most changes to it for the new exam. And anything that's a new question is in bold. And this again allows you to use a study aid or an exam aid. So there's two files that you can download from the ISED website. So a study aid, which you can't use in the exam, and reference material or exam aid, which you can use in the exam. So this is an example of the study aid. So it gives you the formula and it also gives you what it means. And here's an example of a diagram. So here, it tells you what the diagram is. Then it labels all the stages of it. And this uses standard symbols that are used in electronics. So this is an antenna, this is an amplifier, that's a filter, this is a mixer, that's an oscillator, this is a detector or diode, another amplifier, and that's a speaker. Or here is a typical HF installation again, linear amplifier, a filter, SWR meter, antenna tuner, a switch, antennas, dummy load, which is a resistor, and the HF transceiver. Now, when you look at the same reference material or exam aid you can bring into the exam, it gives you basically all the formulas, but it doesn't explain what they are or what the letters stand for. And again, it doesn't tell you again what this is. So this is a receiver because antennas on this side, speaker is here, and because this is a diode, you know that it's an AM receiver. But again, it doesn't label any of the components. And here, for example, is a typical HF station. Again, it doesn't have any of the things labeled. But you could, and what they used to ask you is, where is, this amplifier located between here and here? But now the question most likely will be, what's the purpose of this amplifier? So the questions are different. So 3 is operations technical, and now we're covering section 6 up to section 10, and then we'll cover the rest next week. So here is SSB transmitter layout. So here's a new question. In a single sideband transmitter, what does the fixed RF oscillator do? So C is the correct answer. It produces the RF carrier. Here is another question. In a single sideband transmitter, why is the speech amplifier needed? So the microphone usually produces a low power output. So a speech amplifier amplifies your voice into a stronger electrical signal. So C is the correct answer. Here's a new question. In the typical single sideband transmitter, what is the purpose of the filter that follows the balanced modulator? So after the balanced modulator, it removes the unwanted sideband. So the mixer generates both the upper sideband and the lower sideband, but you want to remove that. And so you have a filter there and it removes the unwanted signal. Here's another new question. In a typical single sideband transmitter, at what frequency is the sideband filter tuned? So in this case, it's tuned near the fixed RF oscillator frequency. So A is the correct answer. In a single sideband transmitter, what is the purpose of the speech amplifier? And so D is the correct answer. It amplifies the audio you wish to transmit. Here's a new question. In the single sideband transmitter, which stage transposes the single sideband signal to the operating frequency? So what the correct answer is here is the mixer. In the another new question, in the single sideband transmitter, which stage allows you to adjust the final transmitter frequency? So that would be your variable frequency oscillator. So C would be the correct answer. Another new question, in a single sideband transmitter, which stage normally includes a circuit providing protection from excessive SWR? So that would be the final amplifier. Usually has some sort of protection circuit, and the final amplifier is connected to the antenna, usually. Another new question. In a single sideband transmitter, which stage transposes the voice message from an audio spectrum to a radio spectrum? So in this case, you're looking at some sort of modulator. The correct answer is here B, balance modulator. Another new question. Which of the following is a function of the sound card interface in the station operating computer-based digital systems? So when you go through here, B is the correct answer. To convert the received analog audio signal from the transceiver into a digital signal for the computer. So that's what the sound card does in a computer. The sound card may be actually part of the computer, or it may actually be part of the transceiver. So B is the best answer. There's another, so now we're on digital radio systems. So I want to mention here that this section also has been completely redone, and it eliminates all of the previous things, relating to packets and to TNC. So this has been all updated to the new technology.
Yeah, that's what's been missing recently in the course.
Yeah. So all these questions have been updated.
Good.
So here's another new question. Which of the following is a function of the sound card interface in a station operating computer-based digital systems? So again, this is to convert the digital signal from the computer into an audio signal that can be transmitted. So B is the best answer. Another new question. Which of the following is one function of the most sound card interfaces in a station operating computer-based digital modes? So another function of the sound card is to switch the transceiver between receive and transmit modes. So B would be the correct answer. Here's another new question. Which of the following is a function of the sound card interface in the station operating computer-based digital modes? So again here, to provide an audio frequency coupling between a computer and a transceiver. So B is the correct answer. Another new question. Why are isolation transformers often included in the sound card interface of a station operating computer-based digital modes? So usually when you have you talk about isolation and transformer. So C is the correct answer, to prevent the coupling of the transceiver and the computer from introducing hum and interference into the transmitted signals. Another new question. Why are some transceivers capable of operating computer-based digital modes without a separate sound card? That's because the sound card is built into the transceiver, and that means also that they have to have an audio codecs, which translates the signal into a certain type of audio uh, signal. So C is the correct answer because they incorporate audio codecs. Now we're getting into the another section, power supplies. This has also been updated where they don't ask you where are things located, but now more about what things function. So here's a new question. In a linear power supply, if a linear power supply provides overvoltage protection, where is the overvoltage protection monitored? So, so the best answer is A, at the output of the regulator, because that's the closest to the output of the power supply. Another new question, what is the purpose of the transformer in a linear power supply? So the linear power supply converts AC mains voltage either up or down as required and also provides isolation. What is the purpose of the rectifier in a linear power supply? So the rectifier converts alternating current into direct current. So C is the correct answer. What is the purpose of a filter in a linear power supply? So A is the correct answer, to smooth out pulsating direct current. So it smooths out the direct current. So A is the correct answer. And this is usually a capacitor and maybe a choke also, but typically just a capacitor. What is the purpose of a regulator in a linear power supply? So a regulator ensures that the voltage stays constant when the demand of the supply varies. So C is the correct answer. Here is a new question. In the linear power supply, which stage typically requires a heat sink? So that would typically be the voltage regulator that would have a heat sink associated with it. So D is the best answer. So that concludes the section on power supplies. Now we get into Yagi antennas. So here they ask about different components of a Yagi antenna. So and there's also a picture of a Yagi antenna on the study aid and in the exam aid. Which component of a three-element Yagi is primarily for mechanical support? So that would be A, the boom, because it holds the three other elements. In the three-element Yagi, which is the longest radiating element? So that would be the reflector. In the three-element Yagi, which is the shortest radiating element? So the shortest one would be the director, which is C. And in a three-element Yagi antenna, which element is considered to be, which is, let me rephrase that, which element is connected to the transmission line? So that would be A, the driven element. That's what's connected to the transmission line and to your transceiver. We'll cover antenna and transmission lines in more detail in another section. So now we get to receivers. So which series of emission modes listed below is the order of nearest bandwidth to the widest bandwidth. So what you so typically CW is the narrowest one, and FM voice is the widest one. So B would be the correct answer. And single sideband is between CW and FM voice. The figure in a receiver specification which indicates its sensitivity is the so C is the correct one, the RF input signal needed to achieve a given signal to noise ratio. So how sensitive is your receiver? There is a new question. What are the two signal parameters presented to the user on a waterfall display spectrograph of a modem receiver? So when you look at the spectrograph, this is similar to a spectrum analyzer. So it shows D, amplitude, and frequency. So frequency on the bottom and amplitude is the height of the signal. So you can see what signals you're being received and how strong they are with a waterfall display. Another new question. What is the function of automatic gain control in a receiver? So AGC. So the purpose of that is to limit the change in volume due to a large signal strength variation. So what it does is, if you have a very weak signal and a very strong signal, it tries to maintain the gain at a certain level so you don't get a big blast in volume when you're listening to the receiver, the automatic gain control. Another new question. For which of the following emission modes is it important for a receiver to be tuned accurately with 100 hertz? So this is for the correct answer is A, single sideband, because remember you don't have a carrier, so you're actually tuning fairly close to the modulated signal. So it's the frequency becomes quite important for tuning. So it's a single sideband A. In a super heterodyne receiver with an IF frequency of 455 kilohertz, the oscillator runs above the operating frequency. To which frequency should it be tuned to receive a signal of 3.54? So remember here it says above the operating frequency. So what you would do is you would add these two together, 3.54 plus 0.45, which gives you 3.995. So the correct answer would be D. Here's a new question. When receiving a modulated signal, what is the adverse consequence of a too narrow of a receiver bandwidth? So if your filter is set too small, then you're going to lose some of that information from the signal. So D is the correct answer. Another new question is, apart from sensitivity and selectivity, which is the third major indication of receiver performance? So it used to be, frequency stability, but that's not used anymore. So the correct answer now that they're looking for is the dynamic range of a receiver. Another question here is a communication receiver has 4 filters installed in it, respectively designated as 50 hertz, 500 hertz, 2.4 kilohertz, and 6 kilohertz. So if you're listening to single sideband, which filter would you utilize? So typically a single sideband signal will have a bandwidth of 2.4 kilohertz. So you would use the 2.4 kilohertz filter. B is the correct answer. 6 kilohertz is too wide, so you're introducing some noise, and the other filters are too narrow, and you would lose some information of the voice. Another question here. A communications receiver has 4 filters installed in it, respectively designated as 250, 500, 2.4, and 6 kilohertz. If you're copying a CW transmission and there's a great deal of interference, which filter would you use? So here you want to try to use the narrowest filter that you can to eliminate the noise. And because CW has a very narrow bandwidth, so 250 is the correct answer. So C is the correct answer here. When receiving CW, which of these filter ranges is optimum for a bandpass filter? So what you're looking for here is one of the narrowest filters. So typically the correct answer is C, 750 hertz to 850 hertz as a bandpass filter. And this would also set the tone of the signal that you're actually receiving and how you're hearing it. So that concludes this section, and we'll continue on with the next section of section 3 next week. So let me just stop the recording.